You know, there's some trinomials that can be factored into absolutely beautiful ways. I want to share a couple of them with you because they're pretty cool, very important, and we'll see them throughout our journey through math. So first of all, let's just take a look at the trinomial that is a squared plus 2ab plus b squared. All right, now how would you possibly factor that? Well, when we try to actually factor it by grouping, what we see is the two groups are in fact identical. Let's check it out together. A times a squared. Outer terms, an ab. Inner terms, another ab. That's 2ab plus b times b squared. But look, since this thing is the same as itself, I just have that thing squared. This is a perfect square trinomial. What about this? Can you guess what this would be? Well, actually, if you think about it, we can figure it out because it looks very similar to the previous one. I have to think of two numbers whose product is b squared, and yet when I combine them with the a's, I get a negative. So what would it be? The sign would have to be what? Both the same sign, and they'd have to be negative signs. And that's right. We get a minus b times a minus b. A times a squared. Outer term, negative ab. Inner term, negative ab. Net result, negative 2ab. Negative b times negative b is positive b squared. So there we can see that we have a minus b all squared. These are really important and fun. Let's take a look at some examples where you can see this happening in action. Let's try to factor x squared plus 8x plus 16. What I notice immediately is that I can write that in this form. Now check it out. This is actually x times x. I can write this term as 2 times x times 4. And I can write the 16 as 4 times 4. And so you can see the perfect square, and 2 times the product of the numbers themselves. And so immediately I see this equals x plus 4 times x plus 4, or alternatively and equivalently, x plus 4 quantity squared. So when you see something squared, two perfect squares, and in between it's 2 times the x times the 4, the numbers themselves, product, then you know you've got a perfect square. Let's try another example together, just to give you a sense of how you can ride the wave of perfect squares. Take a look at this. 9y squared minus 6y plus 1. Again, I can write this as 9y squared is the same thing as 3y times 3y. I can write the 1 as 1 times 1. That's a perfect square. And what about the thing in the middle? I can write that as negative 2 times what? 3y times 1. 3y times 1. Therefore, this tells me immediately I can write this as 3y minus 1 all squared. So sometimes these things can be factored really, really quickly once you realize that, in fact, we're looking at a perfect square. Okay, you asked for it, you got it. One last one. Let's see if this is a perfect square. X times x. Here I see 5 times 5. The question is, do I see in the middle 2 times 5 times x? Well, no, I'm actually seeing 6 times x to get me to be 12. And 6x does not equal 5x, which is what we need to make this a perfect square. This is not a perfect square. Sadly, this is not a perfect square.